In this lesson, we will be introducing the basic trigonometric functions and discussing the relationship between the angles and the sides of a right triangle. Oftentimes in the real world, we encounter geometric shapes that we can visualize using a triangle. Particularly in this case, we want to use a right triangle. And the reason it's a right triangle is because this bottom angle here is a right angle, which means it's 90 degrees. We often can refer to the other angles using the Greek letter theta. How is the measure of this angle related to the various sides? The hypotenuse is the side opposite the right angle. It is also the longest side in the triangle. We also have the opposite side, and we call this the opposite side because it is the side opposite our angle. I could have called this top angle theta, which means the opposite angle from that would have been the bottom side. The opposite side is relative to which angle you're looking at. And the third side we call the adjacent side. And again, this is relative to the angle. It is adjacent to the angle you're looking at. So how are these three sides related to the measure of our angle theta? And we have three trig functions that give us different relationship. The first trig function is sine. And we have the relationship that the sine of the angle theta is equal to the length of the opposite side divided by the length of the hypotenuse. The second function is cosine. So we have that the cosine of the angle theta is equal to the length of the adjacent side divided by the length of the hypotenuse. And the third function is tangent. And so again, we have the tangent of the angle theta is equal to the ratio of the opposite side divided by the length of the adjacent side. How can we use these functions to solve problems? Let's look at some examples. Suppose an escalator is designed with a 38-degree incline angle. If the length of the escalator is 18 feet, what is the vertical height at the top of the escalator? So if we look through this, we know that it has an incline angle of 38 degrees. So that is theta. We also know that the length of the escalator is 18 feet. So that's our hypotenuse. And we're trying to find the vertical height. So the vertical height would be the right side, which is the opposite side. For now, I'll call this x. So in order to solve this problem, we have to think about which trig function gives us a relationship between the opposite side and the hypotenuse. And if we remember, we had that the sine of theta was equal to the opposite side over the hypotenuse. So if we plug things in, that means that I have the sine of 38 degrees equals the opposite side, which is x, divided by the hypotenuse, which is 18 feet. To get x by itself, we just need to multiply both sides by 18. So that means x equals 18 times the sine of 38 degrees. Using a calculator, we can easily compute this. The first thing we need to check on our calculator is its mode. The main thing that we're concerned with is whether it's set to radian or degree. And since in our problem we are dealing with 38 degrees, we need to set this to degree mode. So to compute this, we have 18 times the sine of 38 degrees. So we get 11.08. So that means that the vertical height at the top of the escalator is 11.08 feet. Let's look at another example. Suppose an escalator is designed with a 38-degree inclined angle. So again, that's our angle theta here. If the length of the escalator is 18 feet, what is the horizontal length of the escalator? So again, the escalator itself, that's the hypotenuse, is 18 feet. So it's kind of the same setup we had in the first example. What is the horizontal length of the escalator? So horizontal is the bottom side, so that's our adjacent side. So this is the one we're looking for. Let's just call this x. So what trigonometric function did we have that gave a relationship between the adjacent side and the hypotenuse? That was cosine. So the cosine of our angle theta was equal to the adjacent side divided by the hypotenuse. So that gives us that the cosine of 38 degrees is equal to the adjacent side, which is x, divided by the hypotenuse, which was 18 feet. And again, we can multiply both sides by 18 to cancel the right side. So that gives me 18 times the cosine of 38 is equal to x. This time we have 18 times the cosine of 38 degrees, which is 14.18 feet. And that's the measure of the bottom side. One more example. Suppose an escalator is designed with a 42-degree inclined angle. If the horizontal length of the escalator is 20 feet, what is the height at the top? So this time, our angle theta is 42 degrees. The horizontal length is 20 feet. So the horizontal length would be the horizontal distance of the bottom side. So that means that the adjacent side is 20 feet. And the height, that's the opposite side. So we're trying to find the opposite side this time. So what trig function gave us a relationship between the opposite side and the adjacent side? And that was tangent. So we have that the tangent of our angle theta is equal to the opposite divided by the adjacent. So that gives me the tangent, and this time it's a 42-degree angle, equals the length of the opposite side, which is x, divided by the adjacent side, which is 20 feet. And to get x by itself again, we can multiply both sides by 20. And so we get that x equals 20 times the tangent of 42 degrees. So we need to do 20 times the tangent of 42 degrees, which is 18.008. Or if we rounded it, it would be 18.01. So the length of the opposite side is 18.01